So how can we create a copy of an object, and what are the different ways we can do it? So can you tell me what is garbage collection? Can you tell me what's an interface in Java with an example?
Okay, so an interface in Java is
Hello Aneeq, my name is Rishi. Thank you for taking the time to come and talk with us today. As this is a Java role, today I'll be asking you about your Java background.
all right. Thanks, Rishi. Looking forward to it. Yes.
Great. So let's get started. So I'm going to start off with asking you about tell me, is Java platform independent, and what does that mean?
Yes, Java is platform independent. So what platform independence means is that in Java you can write code in any platform, and it will run also on any platform irrespective of where it was written. What I mean to say is, for example, if I write the Java code and compile it in Windows, and then I take that compiled code and I run it in, let's say, a Mac OS or Linux, it will still work because the Java code is being written for the JVM, that's the Java virtual machine, and the JVM runs it on all of these platforms. So Java is platform independent because it writes for JVM.
I see. So you mentioned JVM there. So what is JVM?
So JVM is the Java virtual machine. What happens is when we write a Java code, the Java code gets compiled down to something called bytecode. This bytecode is what is used to run on the JVM. So the JVM makes sure that our Java code is platform independent. The JVM converts this bytecode into machine readable code. Now that machine readable code is different for different platforms. So the JVM specifically is not platform independent. The Java code is, but the JVM is different for let's say Unix system versus a Windows system, and it is as per the environments over there. So the JVM converts the bytecode into machine readable code for that particular platform.
Okay. And so what is the difference between JDK, JRE, and the JVM?
Right. So the JDK is the Java development kit. It is like the superset. It consists of the JRE and the JVM. So JRE is the Java runtime environment, and the JVM is the Java virtual machine. So what happens is the JDK is where it consists of JRE plus some libraries. The JVM consists, so the JRE consists of the JVM plus some libraries. So when we finally run the code, that is what JVM does. It takes the bytecode and converts it into machine readable code.
Okay, good. So tell me, what is the importance of this main method in Java, and what is its syntax?
Okay, so the main method is the first method or the entry point for the program to even start running. So without the main method, the program won't even run. The syntax for it is we need the main method to be public, static, void, main. What all of these means is public means that it can be accessed from anywhere. That is any function or any point outside the program can actually access it. We don't need specifically some permissions to access it. Static means that we don't need to declare a specific object for it. That means that the main method belongs to the class that we are talking about, that we are trying to run, and not specifically the object. Otherwise, the compiler would have to create an object just to run that. And then void basically just means that we are not returning anything. Within the main, we take arguments of a string array called string args. That's what we usually say. Now, this args array can be blank. We can have no arguments over there. What this is for is that the string args gives command line arguments. So let's say if we are running a program that concatenates or joins two files, we can actually pass the name of these two files in the arguments array.
And you mentioned a compiler, right? So have you heard of a JIT compiler? What is it?
Yes. So a JIT is a just-in-time compilation, right? So what happens is, as I mentioned before, the JVM takes the bytecode and converts it into machine readable code. Now imagine if we had some code that is being continuously called. Let's say it's a method, and this is a very common method. Let's say just to add two numbers, right? So now every time that this method is called, the JIT compiler or the just-in-time compiler, the Java compiler would have to convert this byte code into machine readable code again and again. What the JIT compiler does is it understands that, you know what, this code is being called again and again. Why don't we convert it into machine readable native code at the outset, at the beginning itself, and then we need not convert this method again and again. So the just-in-time compilation will just call the native code, and it won't again and again compile that byte code to machine readable code for some methods.
Right. So you may have heard about pointers.
Yes.
Can you tell me what is it and does Java support it?
All right. So from what I know about pointers is basically a variable that stores the address of it's used to store the memory address of a certain variable, and it is used to then do manipulation, that is move forward, move backward, and get the various variables at different addresses. Java doesn't really have pointers. The closest thing to pointers in Java is an object reference. So when we declare a new object in Java, there are two parts to it. There is one is the instance itself, and one is a reference that is pointing to the instance. It's not pointing to the memory location, it's just pointing to the instance of it. So if we want to access that object, we use the reference. So the closest thing we have to a pointer in Java is that reference.
Right. So Aneeq, you mentioned about static method before. Can you tell me what is a static method? Why is the main method static? And what happens, say, if you don't give the static modifier?
Right. So what the static keyword does is it tells us that the method belongs to the class and not to the object itself. So if we have, let's say, like the main method as static, we are telling the compiler you don't need to create an object to access this. Rather, we can just access it using the class itself. What the static keyword does is, or rather, if you don't use the static keyword, then that method is a method of the instance. That is, we need to create an object for it. If we don't declare the static keyword for the main method, then the compilation happens, but it will give us a runtime error, which is a no such method error.
So can you tell me more differences between static versus instance methods?
Okay. So a static method is the one that actually belongs to a class, whereas the instance method is the one which belongs to an object. That is, for the static method, you don't need to instantiate an object to call it. For a non-static or an instance method, we need an object to call it. For a static method, we can only access other static variables from the methods. Whereas for an instance method, we can access both the static variables as well as the instance variable from the method. Obviously, for a static method, we need to define the static keyword. For an instance variable, for instance method, we don't need to define the static or modifier.
So Aneeq, let's talk about strings now.
Sure.
Can you tell me what's the meaning of immutable in terms of strings?
So in Java, strings are immutable in the sense that once we define a string, it can't be changed. So for example, let's say I define a new string called string name is equal to Edyst. Right? So this Edyst can't be changed later on. If we want to modify this name, that is, we want to call it string name is equal to name plus interview, right? So it will create a new string called Edyst interview, but the previous Edyst still exists. So all that's happened is that the reference is now pointing to a new string, but the previous string still exists. So that any string object is immutable, it can't be changed.
So what happens when we declare a new string, and what is the string pool?
So when we declare a new string, Java takes that string and stores it in the string pool. So for example, if we do string name is equal to Edyst, a new string is created and it's stored in the string pool. If we create another string, let's say string name 2 is equal to Edyst, it will not create a new instance for that string. It will first check in the string pool whether an instance of that same value exists or not. If it exists, then it's only going to point to that particular instance. This helps Java save memory. If we explicitly wanted to create a new instance, we have to use the keyword called new.
So Tell me what's the difference between a string buffer, and a string builder?
Right. So a string is an immutable object, and whenever we create a new string object, it first goes into the pool. Any new object that we create, first it checks with the pool if it's there or not. A string builder is very similar in terms of the string, except that it is a mutable object. So whenever we want to create those objects that we're constantly going to change or going to do a lot of manipulations on, we would rather use a string builder. A string buffer is also a mutable object, and it is similar to a string builder, except that string buffer gives us thread safety. That is, it is a synchronized object. So if we are going to use multiple threads, we should use a string buffer.
Right. So let's now talk about exceptions and exception handling in Java.
Right.
Can you tell me what is an exception? What is exception handling?
So an exception is any error that disrupts the normal flow of a program. These are generally not caught at compile time. For example, we could write a program to divide two numbers, right? And we write something like int c is equal to a divided by b. Now, this is not wrong. So the compiler will not throw us any errors. But let's say if the value of b is 0. So division by 0 is not allowed, and that is an error. Now, this has disrupted the normal flow of our program. So any of these runtime errors, this is what is called as an exception. Exception handling is the process of actually catching these exceptions and handling them when these exceptions arise.
Right. So tell me about the try, catch, finally blocks in Java.
So the try, catch, finally blocks, these are used to handle exceptions. Let's say we write some code in a try block. This is any of the code that we think is going to throw an exception. We put it in a try block. Then whenever an exception occurs, we catch that in the catch block. So if an exception is thrown, we'll tell it what it has to do in the catch block. And the finally block executes no matter what. Let's say if there was an exception or there wasn't an exception, we still want to use the finally block to wrap up our code. So the finally block is executed whenever, irrespective of whether an exception is thrown or not.
So tell me what is exception propagation and what's the difference between checked versus unchecked exceptions?
So exception propagation is when let's say our program throws an exception. So the exception keeps propagating up till it finds a certain code that can handle it, right? So that is called exception propagation, that it keeps going up till a certain code can handle it. There are two types of exceptions, mainly checked and unchecked exceptions. Checked exceptions are those that will actually not let us even compile the program. So there are certain exceptions like file not found exceptions. What the compiler will complain is that either you wrap it in a try catch block or you explicitly say that this throws an exception using the throws keyword. So this is a checked exception which the compiler itself checks for. An unchecked exception is one which is not checked by the compiler, and it is something that we have to personally account for. So most of the runtime exceptions are unchecked exceptions. Anything that's not in the runtime exceptions is a checked exception.
Right. Aneeq, please tell me more about classes and objects and their differences.
Alright. So a class is like a blueprint or a template. It's a user-defined blueprint. It has the plan for what the objects are going to store. So it generally defines the plan in terms of member variables and methods, but it just gives the definition. The object is the one that actually has the instance of this class. The object is the one that holds state for this class. To give you an example, let's say we are modeling the students in a school. So a student we know has to have the properties of an age, a name, a roll number. The age could be an integer, the name is a string, the roll number is again an integer, the marks, which is an array of integers. So now we've defined this plan. But for us to actually define this for a student, we have to create an object for that student. So the class is just defining the plan, and the actual instance is the object.
Okay. What is a constructor? How many types of constructor are there and their differences?
Right. So as I said, an object is an instance of a class. So what constructors help us do is constructors help us assign values to that object. So a constructor is defined within the class. It has the same name as the class. It doesn't have any specific return type. Um, Constructors themselves are of two types. What happens is when we create a new object, this constructor is called, and though it doesn't have a specific return type when we define it, it returns an instance of that class, or it returns an instance called the object. There are two types of constructors. There is a default constructor and a parameterized constructor. The default constructor is also called the no arguments constructor. That is, it does not take any arguments, and it is just there to give default values to any of the variables that we have already defined. The parameterized constructor actually takes arguments. So let's say we want to set custom values to these variables, then we use the parameterized constructor. Just to give an example again, in the student object, let's say we want every student out there to be of a certain age, to be of a certain roll number, and to be have certain marks. So we can just define all of those values in default constructor. If we want to give a specific value to that at the time of object creation, that is, we want to give a specific roll number or specific name and specific marks, then we would use a parameterized constructor.
Right. Can you explain OOPS concepts such as abstraction, encapsulation, inheritance, and polymorphism?
Right. So all of these four concepts, that's abstraction, encapsulation, inheritance, and polymorphism, all four are the pillars of object-oriented programming. Abstraction is where we define a certain functionality, but we don't really know how it's being implemented. So just to give you a real world example, let's say we have a television, and when we turn on the TV using a remote, we don't really know how the TV remote is working or how the TV is working to turn on, but the functionality has been abstracted. Similarly, in Java, we could be using a method like the sort method that Java gives us for sorting the elements of a certain collection. Now, how that exactly happens, we don't know. There are many optimizations that Java does, but it has given us that abstraction of a sort method. So that's abstraction. Encapsulation is when we encapsulate both the data and its functionality into one unit. So, for example, we could have private variables in an object, and to access those private variables, we are using the concept of getters and setters. Now, these getters and setters are the only ones that are going to access the private variable. Any change that has to happen in the private variable is now encapsulated in this setting. So what happens is, let's say we have a private variable called a password, and we want to set that password to a blank password or an invalid password. The setter, we can define the setter not to allow us to do that, or rather ban us from doing that. Now, the functionality of that has been encapsulated in this object. We don't have to create another method somewhere else to do it. So this is encapsulation. Inheritance is when we have classes or objects that have similar behaviors, but they're a little different in places. We would want to have the general behavior in one class and the specific behavior in the children classes. So again, to give an example, let's say we have a vehicle class. Now this vehicle tells us that every vehicle has to have certain number of wheels, it has to have the ability to accelerate, to brake. So these are all methods. But the implementation of each can depend on vehicle to vehicle. So what we do is we create a parent class that is the vehicle class, and any of the other vehicles that we want, we inherit from this parent class. So inheritance allows us to use the general code and then override it or define again some specific code that we want to do. Finally, polymorphism is when we are using the same name or the same definition, but for different purposes. So for example, we could have a method in a class, say the name of the method is called add. We could have two methods. One is that takes parameters to integers and it gives the result of the sum of the two integers. We could have another method, again called add, which takes parameters to strings and gives us the concatenation or the joining of those two strings. Now Java allows us to do this. The function of both of these is similar, but they are not the same. One takes integers, one takes strings. Yet they have the same name. And so this is called polymorphism, where you can use the same name but for different things.
Good. Can you tell me why Java is not a pure object-oriented language?
Right. So Java is not a 100% object-oriented language because to be 100% object-oriented, everything in Java would need to be either a class or an object. But we have certain primitive data types in Java, and these primitive data types are not objects or they're not classes. So that's why Java is not a pure object-oriented language.
So, which brings me to the question: what are object references, and how are they different from primitives?
Right. So in object reference, that is when we create a new object, like I said, when we create a new object, we invoke the constructor. The constructor returns the instance of that object. So now we are assigning an object reference an instance. So the object reference points to or refers to an object instance. If we make a copy of this object reference, let's take the student class. So that is, we define a new student object called student. My student is equal to new student. So now my student is the reference and it has an instance of the student class. When I do something like student, my student 2 is equal to my student, the object reference of the first one has been copied into the second object reference. Now, both of these object reference are pointing to the same instance. So here we are using object references separately and of the object instance separately. In primitives, this is not the case. In primitives, let's say I define an integer, let's say int a equals to 5. And then I do something like int b is equal to a. Now both a and b have values 5, but these are separate values. They're not the same value. So if I do a is equal to a into 10, so I will get a's value as 50, but b continues to remain as 5. So this is how it is different. In an object reference, the instance and the references are separate. In a primitive, that's not the case.
So, how can we create a copy of an object, and what are the different ways we can do it?
Right. So it is possible to create a copy of an object. What happens is, if we just use, like I said, the equal to operator, that is my student 2 is equal to my student, all we are doing is making a copy of the reference. We are not actually creating a copy of the instance. To create a copy of the instance, we would need to implement the clonable interface. The clonable interface gives us a clone method. By default, what the clone method will do is, if there are two objects, it will create a clone of the object, or rather there's one object. If you want to clone that, will create the clone of that. But if there are object references within the first object, it is not going to create a copy of those object references, or rather the object instances also. It is going to create a copy of the object references. So this is called a shallow copy. If we want to do a deep copy, what we need to do is further extend this clone method and define how we want to do the deep copy. That is, we want to not only copy the object references, we want to copy the instance also. That would be a deep copy.
Right. So, can you tell me what is garbage collection?
So, garbage collection is this feature from Java that it continuously looks at the heap and sees which object instances don't have any references pointing towards it. So if there is no reference that is referring to that instance, Java knows that we can actually just deallocate the memory and take it out. So this is an automatic feature of Java, and we really don't need to interfere with it too much. But the Java the Java language itself runs this garbage collection.
Can you tell me what's an interface in Java with an example?
Okay, so an interface in Java is it is an entity that defines certain methods, and it tells a class what it should do, but not how it should do it. So any class that implements that interface needs to define all of the methods of that interface. For example, we could have a car interface. Now, any car that's implementing this interface needs to implement all of the methods of that car interface. For example, the methods could be drive, brake, turn, accelerate. Now, any car that implements this car interface needs to define all of those methods.
How about abstract classes?
An abstract class has a similar concept. An abstract class is those classes that are just meant to be inherited from. We don't create any objects of that abstract class. We just inherit from that class. Any class that inherits from the abstract class needs to implement all of the abstract methods of the abstract class.
So, can you tell me the difference between abstract classes and interfaces?
Right. So there are some differences between an abstract class and an interface. The number one being that abstract classes you can only extend one abstract class at a time, because in inheritance we can extend only one class at a time. In an interface, we can implement multiple interfaces at a time. Apart from that, an abstract class can have instance variables, and interface cannot. An abstract class can have static variables, an interface cannot. A abstract class can have a constructor, and interface cannot.
Aneeq, we'll continue with more questions on OOPS concepts in Java.
Sure.
Can you tell me about overloading and overriding in Java?
All right. So method overloading and method overriding, these are both concepts of OOP. What happens is method overloading is when we have a method, two methods with the same name but different parameters within the same class itself. So we could have a method called add. This method takes only one parameter, and then we have another method called add, which takes three parameters. They are both within the same class. This is called method overloading. So the differences in the method signatures, that is the arguments, will tell us which method we are going for. Method overriding happens in inheritance. So we have a parent class that has defined some method with a certain method signature, that it takes certain parameters. And we could have a child class that has the exact same name and exact same signature, that is the exact same parameters. This child class method will override the parent class method. This is called method overriding.
Right. Can you tell me what is an access modifier?
So access modifier are keywords like private, public, protected, which actually define how much access or what are the resources that can access a particular method or a variable.
How about this keyword? What does it do?
Alright, so this keyword is used a lot in inheritance and other places. There are four main uses of the this keyword. This keyword is used to refer to the variable or method of the particular object that we are in. That's one. Second, this keyword is also used to invoke the constructor of our current object. The this keyword, it can also be used to pass the current object in a method parameter, and also if you want to return the current object, we can use the this keyword.
Right. Can you tell me more about what does the super keyword do?
Alright, so the super keyword is similar to the this keyword in some ways. The super keyword is used to access the variables of the parent class. Super keyword is used to access the method of the parent class, and also if we want to invoke the constructor of the parent class, we can use the super keyword.
Right. So can you use both this and super in a constructor?
Right. So if in a child class, if we use both this and super in a particular constructor, it's not possible, because the first line has to be either this or super. So both of them can't exist on the first line. So we have to choose one of them.
Can you tell me what is the final keyword in Java?
So the final keyword in Java has a few uses. The first use is that if we declare a class to be final, then what we're saying is it can't be subclassed. That is, we can't inherit more from this class. This has to be the final class. There can't be any child classes. That's one. Two, within a class, if we define a method to be final, then that method cannot be overridden by the child classes. So even though the child, we can inherit from this parent class, we can't override this particular method. We can also define a instance variable to be final. This means that that variable can now not be defined again. The state of that variable can change.
Aneeq, let's talk about multithreading in Java. So what is multithreading?
Alright, multithreading in Java is a way of running multiple threads at a time. We would want to do this when we want to save time or better use time that our program is using. For example, there could be one method in our program that is constantly waiting for an IO input, like something like an input from the keyboard or an input from the mouse. Now, while we are waiting for that, there could be other parts of the program that can still be running. So we put those parts on another thread and this IO part on another thread. Like that, we can divide our program into different threads which each can run parallelly, which are basically just trying to save time so that while we are waiting in other parts, the other threads can still run. So this is multi-threading.
And what are the various life cycle states in a thread?
Okay, so there are different states in a thread. There are 6 different states. Number 1 is the new state, and this is when just the thread is created. The second one is a runnable state. This is when the thread is actually running. Then there is a block state. The blocked state is when the thread wants to enter into a method or wants to get a certain resource, but it is blocked because another thread could have a monitor for that resource. So it is now blocked because it wants to enter into a synchronized method, but it's not being able to. Then there is the waiting state. The waiting state is when the thread is waiting to enter another thread or is waiting for another thread to close out. For example, this could be that it is waiting for an object.notify or an object.notify all to be called on this thread, or it is waiting for a thread.join, in which case it is waiting for a thread to terminate. There is also a timed waiting that while it is waiting, it could either be waiting for another object to notify it to join it, or it could be waiting at a specific time. And finally, there is a terminated where the object has where the thread has terminated.
Right. So what's a deadlock and what is synchronization?
Alright, so a deadlock occurs when we have more than one thread trying to ask for a synchronized method, but each has the monitors of each other's synchronized method. What I mean by this is, in Java, we have a certain thread and we are using a certain method. Now that method is synchronized. That means it has a certain lock that only it can be used by one thread at a time. So let's say we have thread 1 and thread 2, right? And thread 1 has the lock of a certain object or method, and thread 2 has a lock of a certain object or method. What thread 1 wants is that it wants to give up this lock, but it wants to acquire the lock of thread 2's object. And thread 2 wants to give up the lock of its own object and wants to acquire the lock of thread 1's object. Now both of them are waiting for the other thread to give up their lock. This is called a deadlock, and we would want to avoid it. Synchronization is nothing but making sure that each object or method can be used by only one thread at a time. So it has a monitor or a lock, which if it's synchronized, it can only be used by one thread at a time.
Right. So now tell me, what are some ways to avoid deadlocks?
Right, so we would want to avoid deadlocks, otherwise the program can just crash. So one of the ways we can avoid deadlocks is by ordering our locks. That is, we make sure that we acquire lock 1 or lock 2 in a certain order. That is, I will acquire lock A, then I will acquire lock B, then I will acquire lock C, then I will acquire lock D. That is, if we have this order defined in a certain class, then any thread that wants to acquire lock B has to have acquired lock A first. Now, it cannot acquire lock A because some other thread has lock A. So if we time the locks, then we know that only one thread can actually have all the locks at a specific time. Another way we can do this is by having only one lock at a time. So we make sure that if we want to acquire another lock, we make sure that we give up our current lock and then only go to the next lock. This way, every thread can have only one lock at a time. So if before going to the next lock, it releases our current lock, so that we can avoid deadlocks over there. Another way is timed unlocking or timely giving up of locks. So we set up a process where we are continuously giving up locks from a thread so that it's freeing up locks for other threads. And finally, we face this in a lot of GUI applications where it's just not possible to avoid deadlocks sometimes. So we try to design the entire application in just one thread. So just using a single thread is also a way of avoiding deadlocks.